All right. Properties of exponents. I hope you guys had a good weekend. Those of you who are new to my class, have you gone to the website at all? Yeah. If you're absent, if you go to this website, you can click on, this is chapter 8, so we can click on section 8.1. All right. So if you're ever absent, and I put the homework on here as well. All right, properties of exponents. First property we're going to talk about. If I have a to some exponent, let's call it n, and I multiply by a to the m, I can write that as a single unit, and that would be a to the m plus n. Right? And what that means is, or n plus m or m plus n, either way. What that means is, if I have x to the fourth times x to the third, that's going to equal x to the 4 plus 3, or simply x to the 7th. We don't multiply those exponents. We simply add them. All right? Well, the reason why, if I have x to the fourth, doesn't it mean x times x times x times x, right? And if I multiply by x to the third, which is x times x times x, and I have 7 of them now, right? So it's x to the 7th. So that's why we add the exponents. Okay? Yeah.
So if you're writing this out, like in word form about the actual numbers, you can say that when you have x to a certain exponent plus another exponent, you can add the exponents together.
Correct.
Even if, like, with the m and the n, because they're different, you can still add them together.
Yes. Okay. Yeah, Zach.
Do you still do this if it's like x to the fourth power plus x to the third power?
No. If you go x to the fourth plus x to the third, there is nothing you can do. You can't combine them in any way.
Does it work for division?
It does, but we'll cover that tomorrow. Okay, good questions. All right. So, if I had, let's take a couple of examples like this, all right? Let's take 2x cubed y to the fifth times 3x y to the seventh. And I ask you to simplify that for me. All right? Well, it's really not that hard, because 2 times 3, we can do that. And then x to the third times x would give me x to the what? Fourth. Because there's a 1 there, right? So x cubed times x would give me x to the fourth. And then, of course, we would have y to the 12th.
Yeah, I don't even know what we're doing.
All right, let me go back over this now. What we're doing is I'm multiplying this times this. And 2 times 3 is 6, correct?
Yeah.
That's where I got the 6 from.
So 6x and
X to the third times x gives me x to the fourth, adding the exponents, just like I did up here. X to the fifth times x to the seventh or y to the fifth times y to the seventh is y to the 12th, adding the exponents. Okay?
you know.
Yes. Mr. Joseph,
Yes.
why is y to the third power plus, or x to the third power plus x?
It's not plus, it's times. I'm multiplying.
You're multiplying. I thought you would add the exponents.
She's asking me a different question than what you asked me.
Maybe it's just x 3 times it. I don't get.
Where do you get to 3? Oh, okay. Maybe I'll back up a little bit then. If I multiply x times x, what does that give me? x to the second power. It's x squared. How'd I get the 2? 1 plus 1. But we don't put the 1 there.
I put 3 times 1. You said you're
It's not 3.
It's X.
The 3, that 3 times 2 gives me the 6.
Right, but the other 3 in the 2x to the third power.
X to the third times x will give me x to the fourth. Because I add the exponents. I'm not sure what you're asking me. I'm not sure. I don't think.
Okay.
I don't think this is this hard. I think you're making it up to be the questions you're asking me don't make sense. You know, I'm not sure what you're asking me.
I thought it was multiplying, and I thought 3.
We are multiplying.
She's confused. She didn't know about the x's, but add the exponents, so she was confused because she didn't realize.
She was thinking 3 times 1 is 3, not 3 times 1 equals 4.
She didn't realize that you had to times the exponent, or like you had to add the exponent and times it.
I know you're.
Okay,
I know
Zach?
She thinks that you need to do it.
Okay.
2, 3 times 1. So it'll be 3.
Wait, she thinks that.
Okay.
Anyway, you guys are making this out to be too hard, harder than what it is. All right? Do you have any questions so far on this? Any other questions? Okay? All right. If I had 2 to the 5th times 2 to the 7th, we get 2 to the 12th. We get the exponent. Okay? It's not 4 to the 12th, it's 2 to the 12th. The base stays the same. With exponents, we have a base and we have an exponent. And as long as the bases are the same, we add the exponents. All right? So that's the base, and these are the exponents. So when I say you add the exponents, you're adding the exponents, these numbers up here. Okay? And the base remains the same.
What happens if you have 2 different base numbers? Do you have to just solve them separately?
Correct. In other words, if I had 2 to the 4th times 3 cubed, that's all you can do with that. You cannot combine that in any way. Other than, if you went 2 to the 4th, you're going to get 16. 3 cubed is 27. And you can multiply those together, no problem. But if you have a problem like that, you can't combine it under one expression.
So just make it the same.
So it'd be the same, right? It's just like having, if I had x cubed, y squared. You can't combine those two. It is what it is. Right? I'm going to give you a couple more examples on this. Because I'm not sure you guys really fully understand. Let's say I had, let me take a couple of examples out of the book here. All right. What is the base number? -5. If the bases are the same, what do you do with the exponents?
You add them
You
together.
add them. The base stays the same, and you add the exponents. And why is it 7? Because there's a 1 there. And if nothing is written up there, -5 to the first power is simply -5. So we don't have to write that 1 there. Okay?
What's the difference of it being on the inside and the outside of the
Oh, let's not go into that right now. Okay? Maybe once we understand exponents, we'll talk a little bit more about that. But there is a big difference there. All right? So if I had x squared times x to the 6 times x, and I ask you to multiply those. Summer, tell me what you would get if I did that.
I think x to the 9.
You are correct. Okay? X to the 9.
It's easy.
Because there's a 1 there. And so all we do is add the exponents. Okay? All right. That's property number 1. There's more than one? Oh, there's a bunch. Okay? All right. The next property. Pardon?
I hope that was a lesson.
How many were there today?
Okay. Let me record. Okay, we don't need those types of questions.
Oh, okay.
If I have a to the m power, some number a is the base, m is the exponent, and this is the second property. If I raise it to another power, it's called a power raised to a power. And what do we do here is I multiply the exponents together. Okay? For instance, if I have x to the third and I raise that to the second power, that becomes x to the sixth. Okay? If you want to know how, it's like when you square something, it's like x cubed times x cubed. Correct? When you square something? All right? And now in this situation here, what do you do with the exponents? You add them, x to the sixth. So it's kind of the same thing, isn't it? All right? Bless you. And another property would be if I had, well, let's say AB raised, let's make this M and N, and we'll raise it to the, let's say P power, some power P. And I'll give you the property in terms of letters, and then I'll show you how it might work. This would equal A to the M times P and B to the N times P. Okay, and I'll give you an example of how that might work. Let's say I have x cubed y to the fourth, and I raise that to the fifth power. All right? Let's say I have x cubed y to the fourth raised to the fifth power. Okay? What do you think the answer might be, Kristen? Alex, what do you think? No.
I know.
Okay, Sid?
It would be x to the 16 and y to the 4.
Correct. Multiply the exponents. When you take an exponent on the outside, when we're taking powers to a power, we multiply, and that's what Sydney did. 3 times 5, that's where she got the 15. And 4 times 5, and that's where we get the 20. And that's something you just have to commit to memory. Okay? Let's take a couple more examples of that. If I have 7ab squared times 7a squared b cubed squared. Okay? And can we simplify that? And let's use all the properties that we've learned. All right? And let's make this, well, that's good. I think that's good enough. All right. In the first, by the way, order of operations says we do what first? Parentheses. There's nothing I can do in the parentheses. So what's the second order of operations? Exponents. So let's do these exponents first. Let's do this 2 first. Okay? That would give me 7 squared, a squared, b to the 4th, times 7 squared, a to the 4th, b to the 6th. All right, before I go to the next step, do we understand?
Yes.
Summer, do you understand?
I do, but
Okay.
I,
What's your question?
no, I think I
All right.
And
Yes.
is it distributed properly?
It's not distributive
No,
property.
but is it like that?
No. It goes to everything inside this. So now let's multiply together. What is 7 squared times 7 squared? 7 to the 4th. Perfect. What about a squared and a to the 4th? A to the 6th. Very good. And what about b to the 4th and b to the 6th? B to the 10th. Very good. Now the only thing you can do with that 7 to the 4th is put it into your calculator to get an answer. And the way we do that in your calculator, it's going to hit 7, and then you hit your caret key. It's called a caret key, and it's right above your division key. And that means 7 raised, and then we can put a 4 there. And whatever that is, that's probably 2,400 and something, probably. 2,401. So the only thing we can do here is make this 2,401, a to the 6th, b to the 10th. And yeah, we can do that. I don't think it takes too much to do that. Question?
When you have it written out as 7 to the 4th, a to the 6th, b to the 10th,
Yes?
why is there the 4 there? Because when I was writing it down, I think I lost where we got.
We're 7 to the 4th.
Yeah.
Well, let's break it apart here. I have 7 squared times 7 squared.
Yeah.
The base stays the same, so it's still a 7. And we add the exponents. And it becomes 7 to the 4th.
Okay, so then where are we getting the 6 and the 10?
I got a to the 6th because I have a squared times a to the 4th, and it's a to the 2 plus 4.
So you broke 7. So 7, A, and B are all their own separate bases. It's not
Correct.
7A together.
Correct.
Okay.
They're their own separate bases, and that's a great way to put it. Yes, Zach?
Is there a way to figure out what A is from just 200?
No.
Oh, okay, so it's just
We don't know. It's just some number.
Let's give you A or B.
Right.
Is that just another way of writing it, or 7 to the 4th, A to the 6th, B to the 10th? Is that like the final answer?
Well, and like I said, if you have 7 to the 4th, we can write it as a 2,401. So you get used to using your caret key. Yes, son?
are they ever gonna ask us to find A or B, or is that in the future?
You mean putting in values for A and B? I don't think so. All right. Because there seems to be a lot of confusion, there are a couple of problems with negatives in there, and I'm going to let you deal with that. However, I will tell you this. If we have negative some number, whatever that number is, and I raise it to the 2nd power, is this going to be a positive or a negative? It's going to be a positive. And the reason why is because what this means is negative x times negative x. So your answer will be a positive. if I have negative x to the third power, will my answer be a positive or a negative? Negative. If I have a negative number raised to the fourth power, will it be a positive or a negative? Positive. Evens are positive, yes. Okay. Yes.
Can you give us like an example using numbers, just one?
Well, all right. Positive.
So you don't.
If I have a negative 3 cubed, it'll be a negative. 3 times 3 times 3.
I understand that.
Oh, okay.
I don't understand why you don't take the exponent. Pretend that the negative 3 is just 1.
Yeah. You're looking too much into this problem. All right. I mean, you asked me to deal with numbers, and these are dealing with letters.
Wait, where's 27? Negative 27.
3 times 2.
Negative 3 times negative 3 times negative 3 is negative 27. And if I had negative 3 raised to the fourth power, it is a positive. And where did I get 81? 3 times 3 times 3 times 3. All right? Now, there's a difference. Look at this problem. It is parentheses, negative 3 and then squared. What that means is negative 3 times negative 3. If you were to put this into your calculator, and that is correct. And I don't want to get too much into it today because I think you're still confused with the exponents, but what this says is that you want the negative of 3 squared. That's what that means. The negative of 3 squared, that's why it's negative 9. The first problem here says you want negative 3 and then square it. Negative 3 times negative 3. This one means 3 squared, and then you want the negative of that. So you've got to be careful. But we'll see how you do with the negatives. Do the best you can on what's going to be negative and what's going to be positive. And we'll go over that more tomorrow as you start working with these exponents. Okay? All right. For your homework tonight, I want you to do on page 492. I want you to do problems 3 through 6. And it's going to seem like a lot of problems, but what I want you to do is write out the problems. Okay, write out all the problems. And then come up with the answer. All right? There's not a lot of... I could add on to this. Okay? All right.